Okay, we ever take another integral from the UNSW integration bee 2024. This is semifinals round 1 problem 2. We have the integral from 0 to 2024 pi of the floor of x over pi sine x dx. Okay, the thing I want to deal with first here is just what's going on here with this floor function. We need to take care of that before we can integrate. Now, just a quick review on the floor function. If we have the floor of a non-integer value, like let's say 3.209, let's say, well, the floor is going to round us down to the next highest integer. In this case, that's 3. And if you take the floor of a value that's already an integer, like say 3, that's just going to round us down to 3, or it's going to be just staying at the same value, 3. Now, what we have in our problem is a little different, right? Because we're dividing by pi. So like looking at a few examples of that, what if we looked at, say, 1/2 times pi, like for our, this is going to be our x value. And if we look at that over pi, well, what's going to happen here is the pi's are going to cancel out. So now we're evaluating 1/2. The floor runs us down, and this value is going to be just 0. And so it turns out we can use this. We'll just use a numeric value times pi. So then that way the pi's are going to cancel out. And then when we do this, our numeric value is always going to round down to an integer value. So what I'm going to do is we'll use this to split up our integral. Oftentimes with these problems, I'll split up the integral on just an integer value. But this time I'm going to do it. What I'm going to do, we'll split it up on an integer value of pi. So we'll split this. For this first one, we're going to just go and integrate from 0 to pi. And so this means that all of our x values are going to be between 0 and pi. This is exactly the situation right here. So for everything with our floor function, it's going to be just like this. It's going to round us down to 0. We're going to get a 0 there times sine x dx. Of course, we don't care what else there is because the 0 is just going to zero out everything of this first integral. And then for this next one, we'll do the same kind of thing. We're going to do another increment of 1 pi. So we're going to go from pi to 2 pi. Now this kind of situation is going to be really similar, like a value between, let's just take like 3 pi over 2 being really similar. So if we take that, because that's just an example of an x value within our bounds, then the pi is going to cancel out. We're left with 3/2 there, which is like 1.5. That's going to get rounded down to a value of 1. So everything in this region with the floor, it's all going to round us down to just 1, and we'll just bring over the other stuff. This pattern is just going to continue like this all the way to like 2024 pi. So what we can do, let's just do one more really quick. So this is going to be a 2 pi here. If we're going from 2 pi to 3 pi, everything's going to get rounded down to 2. Now the thing I want to notice now, this right here, if we have like a 1 right here, this value is the same as this value. This 2 value is the same as this value. And then that's just going to keep going that way. We can look at, maybe one thing I can do is actually, I'm obviously not going to do 2024 of these, but I can look at the last one. We can kind of go and just look at this last one. This one's going to be going from 2023 pi to 2024 pi. The floor is going to round us down. We're going to get that value. So we're going to have a 2023 sine x dx. But now I think we see the pattern here. So I just want to kind of generalize this. So let's try to do just one of these. And what I'm going to do for the lower bound, I'm going to call the lower bound n pi, where n is going to be an integer. So then the upper bound, we've always separated by 1. So our upper bound must be n plus 1 times pi. Then again, we saw this pattern that with the floor, we always get the lower bound, not with the pi, but just the lower integer value. So we're going to have an n here, and then we're going to have our sine x dx. And actually, we can look at this as a big sum because we've excluded this first one as that's 0. So we're actually starting with our n value here equal to 1, and it's not going to infinity, it's going to 2024. No, it's actually going to 2023, because when this is 2023, the upper bound is 2024, which is what we have there. So we're actually going from 1 to 2023. But now I can actually just go ahead and integrate this thing. So the n value, that's going to be a constant with this integral with respect to x. So I can actually bring this in front of the integral. We'll bring over our summation. So we'll have our n here. Then we integrate sine, that's actually just going to be minus cosine of x. So I'm actually going to bring the minus up front here just to write it this way. So we'll have this as minus cosine x, and then we just need to evaluate this from n pi to n plus 1 pi. But now we'll just go ahead and evaluate this. I'll bring over the summation again. So we'll have our minus n in front, then plugging in n plus 1 pi, we'll have cosine n plus 1 pi. And then here we're going to have minus, and it's just going to be cosine n pi. But then I can just use this minus sign here, bring it inside, and use this to just swap the sign. So we'll make that a plus, make this a minus over here. And now I just need to clean up the board and we can look at this piece more closely. Okay, for this thing now, let's just write out a few terms of this. So first, when n is 1, we'll just have a 1 in front here. And now here, when cosine's 1, we have an odd n, so we're cosine of pi, that's just going to be a minus 1 there. And then minus cosine n plus 1, now this is going to be 2 pi. Now we have the even case, this is going to be 1. So inside the parentheses, minus 1 gives me a minus 2 here. Then looking at the next one, when n is equal to 2, we have a 2 here. And then what's going to happen here, we're going to end up with cosine 2 pi here, so that's going to be a plus 1. And then here we're going to have cosine 3 pi, that's going to be a minus 1. But minus times minus is plus, and so here this is going to become a positive 2. And then continuing this way, when we have n is 3, now we have cosine 3 pi. Now we're back to this first scenario really, because now we have an odd n. So then this is going to be minus 1 again, this is going to be a plus 1 again, and then here we're going to end up with minus 2. So what's happening here in the parentheses, this is just going to repeat. It's just going to go from plus 2 to minus 2 over and over again. So like at 4, this is going to be a plus 2, and then at 5, minus 2, and it's just going to keep changing based on odd or even sign. But then from here, what I can do, since we've got a 2 and everything, I can actually just factor out a 2. So what I'll do is we'll factor the 2 out in front. Then this first term is going to become minus 1. The second one, this is going to be a plus 2. Then we're going to have minus 3. And then we're going to have plus 4. And you notice all the odd terms have the minus sign, and all the even terms have the plus sign. So what I can do, let's actually just look at the last few terms. So what's going to happen, let's look minus 2021 plus 2022. And our last n value is 2023. So we'll just have a minus 2023 on the end. But then we can just group the terms that are next to each other. 2 minus 1 is 1. 4 minus 3 is 1. And so every pair is going to be, forget about that, but every pair is going to be just 1. But we are going to have this one term at the end, because this doesn't have anything matching with it. So we're going to have to, at the end, we're going to have to subtract 2023 from everything. But now we can really just sum this up, as we still have our 2 in front. Now for all this, we have 2022 terms just going to here, but they're paired up. So because we have 2022 terms paired up, we need half of that. So this value, all this stuff here, this is just going to be 1011. And then we just have this minus 2023 on the end. But now subtracting that, this piece here, we have 2 times this, which is minus 1012. Multiplying it, we get our final solution of just minus 2024, of course. Yep, I probably should have guessed it was going to come out to 2024 somehow. Okay, there you have it. Interesting problem from UNSW 2024. Thanks everyone for watching. Have a good day.